What in the last three classes, what we have done is to look at the concept of depth of anesthesia. Then we looked at awareness during anesthesia. Then we looked at safety in anesthesia. Now, all this focused on certain factors, and what is common in all these lectures that we have talked about is MAC. What do you mean by MAC? That's you have to have a clear concept about what is MAC, so that you can interpret this particular MAC in different situations as it pertains to it. Okay, what is MAC? Can someone define it? Okay, let me define it for you. It is defined as the minimum alveolar concentration of the anesthetic at 1 atmosphere, which produces immobility in 50% of subjects exposed to the noxious stimulus, usually a skin incision. What is the most important statement in this? In this particular statement, what is most important that you should keep in mind? It is the 50% of patients. It is not all patients. It is only in 50% of patients. This particular value that you talk about is effective. In another 50% of patients, it is not effective. So, anytime you refer to MAC, you must remember it is going to be okay only in 50% of patients, but I should make sure in 100% that you achieve it. You get it? So, if you go back to see how this MAC was calculated and how it was identified and became a common thing to use, this is a paper written by Edmund Egger in 2002. He revisited whatever papers he had written before and made this statement. This opening statement here: haloperidol produced by the company was newly discovered anesthetic. That is in 1963. And John asked if we wanted to define the properties, and like good fellows, of course, we said yes. Like the volunteers, you say, how do you define a volunteer? What's the definition of a volunteer? Person who says yes immediately without knowing what he is supposed to do. Okay, he is the volunteer. So, like a volunteer, they said yes, we'll do it. And then he asked him what we should do. He said, go and find out what you have to do. So they went and did a search to find, and so they decided in any comparative study, because they are going to compare halothane with this halopropane, and for any comparative study you need to have an index, you need to have an endpoint. So they defined that endpoint. They said define this common index as a minimal anesthetic concentration in the alveolus required to keep dog from responding to a gross movement to a painful stimulus such as tail clamping or varying electrical currents applied to the sensitive mucosa. Okay, this is abbreviated as MAC. So they defined what they want, what is the endpoint at that time, and said I am going to look at this particular endpoint for comparing the two agents to say what is equipotency between the two agents. So that is how this index came in, mainly to compare the equipotency of the agents that are coming into the market. So they defined it as this, and the MAC was determined for these two agents, and comparison was drawn in terms of effects of various systems in multiples of MAC, and they concluded that halopropane had a narrow safety margin compared to halothane at endpoints at equipotent doses. So therefore they wanted to establish what is the equipotency of the agents, and they defined a marking, and so they reached that mark for both the agents and then compared the effect on the dog. That is how this concept came inside to start with. So then they went on to see, if I add nitrous oxide to this, what happens to this MAC? So if I add a narcotic to this, what happens to the MAC? Because that time the only agent that was there commonly used is halothane. So again this was on the dogs. So they determined that this is what, again they looked at movement, no movement, and 50%. Here this is group A, which these are the ones which moved and these are the ones which did not move. say they took the midpoint at which there is a transition between movement to no movement, and that is defined as MAC. And when you looked at group B, which had the narcotic, there was a 9% reduction in the MAC. Okay, from 0.75 it is 0.68. And when they added nitrous oxide, 70% nitrous oxide, there was a 61% reduction in the MAC, and it came down to 0.29. So that is what the study that was done in 1964. So they defined that reduction in MAC happens when you add up anesthetic agents, narcotics, by about 10%, and you add nitrous oxide, there's almost about 50 to 60% reduction according to the percentage of nitrous oxide that is being used. Okay. Now, what is the method that they have used? They just looked at the movement to non-movement. That is what, and subsequent patients. So, and they went from the higher one to the lower one. So, is that kind of statistics valid to say, to come to a conclusion? And this is a Dixon's up and down method for small samples. This was proposed by Dixon way back in 1965, and it was accepted and it was revisited in 1991. And to say that staircase bioassay up and down method is a very valid method for finding out in small samples what you need, what is the transition between the two. So this has become an accepted method, and in our department, I suppose many of you are aware that we use this kind of method for estimating what is the required dose that we have to give. Okay, so experiments are conducted to estimate threshold for all or none large. See, either you have a response or you don't have a response. In that kind of a cutoff, we use this particular method. And then, still examples are death in a fixed time period, shock, fibrillation, MSC, that's what it is. Staircase design in the particular up and down trials produce a median ED50. Again, you are looking at the median ED50 and not an absolute value which divides the people. So it's only in 50% of patients you are coming to this particular value, and so you should keep in mind it is the ED50, not ED100 or ED95. How did Vega go about finding out this MAC? What did they do? They anesthetized 7 dogs. Okay, that is calculated in 7 dogs, anesthetized for almost 8 hours continuously. And they used a tail clamp method, that is, you clamp the tail and look for a moment. And so it is up and down method. So if the dog moves, you increase the concentration by a fixed percentage, and you they waited for minimum 30 minutes before testing it again, because they wanted an equilibration between what is given from the circuit to the body. So they thought, what is the minimum time we'll have to allow for that equilibration? They arbitrarily fixed it at 30 minutes. So every time they changed the concentration, they waited for 30 minutes to test again. So that is why it went on for 8 hours, the dogs. And up and down method is used, and the midpoint of movement to no movement is plotted as MAC. And this is how they plotted for about this up down. So that is how it was calculated. And then they came to conclusion, this is what is the MAC for halothane in this. Did they stop with this? Is it valid? If you say this is what I have done, and then this is what is my end result, they were not satisfied. Others also will not be satisfied. So what they did, the dogs were recovered. After 15 days, they re-anesthetized the same dogs and then re-estimated the MAC in them again, the same dogs. So it becomes a control, and also as well as this is the testing dogs. They serve themselves as a control. So MAC was again determined the same dogs. Variability between the two instances are determined. The variability is 0.07%. So they could reproduce the result that they found in the first time at the second time in the same dog. So this became validated, saying that yes, this is it's a validated method for measuring the MAC value in any experiment that you are doing. So that is how this MAC was validated in the same dogs, re-anesthetizing them and re-establishing the values. Okay, remember it was done in small number of dogs. It's only in 7 dogs that was done, but it was accepted worldwide, and it is still we are following what has been established at that particular time. Now, what about the effect of acidosis on this MAC? They took 3 dogs and then they anesthetized them, and they produced acidosis by infusion of ammonium chloride, and they brought down the pH from 7.3 to 38 to 7.2. So that's what it is. The pH is brought down to 7.2. When the pH is brought down, the MAC value of halothane also came down. So they established if there is an acidosis in the body, then the MAC requirement MAC is less than what is actually plotted in normal people. Can you correlate this to the patient that you are doing? If you have an emergency patient in emergency and the patient is in acidosis, the amount of anesthetic that the patient needs is going to be less than what you normally give to a normal person in an elective case. So that should be the interpretation in your mind when we get this value to say that if there is an acidosis, then the MAC value comes down. Even though it has been done only in 3 dogs, it holds good for the entire population. And again, they took the sodium bicarbonate infusion to bring back the pH to 7.4, and the pH moved up. And it was repeatable. They produce acidosis, they produce brought it back to normal, so the MAC value also went up. Okay, that is how it has been established. Am I standing on the way? All of you sit here. I don't know. I stand here and all of you sit here. Nobody goes on that side. Okay, so that is that's what it is. On the way. So acidosis brings down the MAC, and normalization of the pH back to the normal level takes it back to normal. The MAC value also goes up. There is a correlation between the acidosis and the MAC requirement. Again, they looked at what is the effect of this MAC, this hypotension on MAC. Now, they produced a fall. How did they produce a fall in the cardiac output? They produced a hemorrhage. They took out the blood from the dogs and produced a hypotension. And then look at the requirement of MAC. What happens to MAC when the person is hyperperfusing? There is a low cardiac output state. And they found the MAC value dropped. So there was a reduction in the MAC value when the patient is hypotensive. And they tried to take it back by infusion of fluids back into, and took the pressures back to the normal levels, but they did not find a change in the MAC requirements. It did not go up again. And they produced a hypertension by infusing phenylephrine and took the BP up to 150, more than that. And still the MAC requirements remained the same. It is at a lower level. It did not correspondingly go up. So what does this mean? What do you interpret from this particular study? What they have interpreted? By infusing vasopressor, we are presuming that we are taking the cardiac output up, which is not so. We are only increasing the pressure head. The cardiac output is possibly coming down because of the increase in the resistance and the volume. And the volume that has been replaced is with fluids. You have produced a hemorrhage to produce a reduction in the cardiac output, but you have brought it back to normal by infusing fluids. And so this is not an acceptable method to say whether the requirement of MAC will come back when the volume is restored or the cardiac output is restored. So and this is an assumption which is a wrong assumption, so there is no response to the requirement of MAC. Once you have produced that fall and the cardiac output, you cannot interpret the cardiac output unless you measure the cardiac output. You cannot interpolate it using a blood pressure as a means of computing a cardiac output. Okay, so how do you compute a cardiac output? Yeah, stroke volume into heart rate. Yeah, stroke volume into heart rate. If you can measure that stroke volume and you know the heart rate, you can calculate the cardiac output. But here they extrapolated the blood pressure to the cardiac output and say it has changed, and it is not a valid interpretation of what they have found. Okay, another thing that they found this is in by Mapleson. They looked at the concept of anesthetic potency. One of the theories is oil gas solubility, and that correlated. Overton's and Mayer's reported anesthetic potency correlated with lipophilicity. Okay, so that is what it is, and they established what is the potency of the anesthetic agent by looking at the lipophilicity. And same way, the correlation of MAC with the lipophilicity is remarkable. The same way, so the MAC value and the potency of the agents could be correlated. If the MAC value, I mean, this is how the desflurane is much more potent than halothane and isoflurane. So that is what the interpretation of this, when you correlate the MAC with the oil gas solubility of the agent. Understood? Because they fall in the same line. Now, this is an 1979, published in Anesthesia Analgesia. Pancuronium reduces halothane requirement in man. The same year, same month, the same article was published in Pancuronium reduces halothane requirement. This is in Anesthesiology in September 79. Same article without any change in even a single word change has been published in 2 journals. How did this happen? This is against publication ethics. If you submit it to one journal, you are not expected to send it to another journal. But here, both from America, both of them decided this is a very important message that goes, and we will publish both of them in 2 journals so that it is widely read by people. Okay, that is how it got published in 2 journals without change in even a single letter. That is how it was. So, and we know the MAC is based on immobility, and muscle relaxant produce immobility. So how did you interpret, after giving a muscle relaxant, how do you interpret the requirement of MAC? Because once you paralyze, the patient is not going to move. So how did you? So we have discussed about it in the last class or something. Can somebody come out with an answer for this? We have discussed it, no? How you estimate the MAC when there is a paralysis? All of you are sleeping or what? Yeah? Yeah, we have discussed it in a different context. See, your mind should interpret whatever information that comes to whatever we have talked about previously. If that does not happen, then you are not learning anything. So what did we discuss on this line? We talked about awareness. We talked about monitoring the awareness. And what is the technique that I described at that time for monitoring the awareness? Isolated arm technique. Good. So this is the technique that they have used, isolated limb technique. For what does it mean? Before giving the relaxant, you isolate the arm by a tourniquet and then give the relaxant so that arm is not paralyzed. And then you go ahead to estimate the MAC, and you find the difference, about 10% difference is there when pancuronium was used, and the MAC value came down by about 10%. So that is what, and later this technique has become norm for testing for awareness. But the first time it was used for predominantly for looking at the MAC value. So they said yes, the muscle relaxant do produce a certain amount of fall, and that can be quantified to some extent. And pancuronium is for halothane produces a 10% fall. See, it cannot be extrapolated that all relaxant reduce it by 10% for all the agents. The interpretation should not be in that line. The interpretation of this should be halothane requirement came down by 10% when you have given pancreonium. If you use any other muscle relaxant, it might be different. Okay, but there is a correlation between the two. That's what they said. Now, so we have been looking at the endpoint, that is MAC, that is ED50 for movement and no movement. That is what we have been looking at till now. People started looking at other endpoints of MAC, that is MAC awake, MAC bar, and MAC endotracheal intubation. So these are the three things. Do you need a different level of anesthetic for this? That is what is analyzed. What is MAC awake? It's ED50 for wakefulness from sleep. Between movement, see here you are saying it is movement to no movement. Here it is wakefulness to sleep. That is what is the transition that they were looking at. So minimum alveolar concentration in man, awakening from methoxyfluorine, halothane, ether, fluoroxane, everything was studied again by that man in 1970. Okay, so what did they find? I mean, they used two methods for looking at this. One is a fast washout method, slow washout method, and the other one. What is that slow washout method? The end tidal concentration was kept steady for 15 minutes at each level of controlled ventilation. And then they looked at the response to concentration at which the patient responds to verbal command is noted as a midpoint of response and no response. So they gave a verbal command for an action to be done, either open the eyes or move the limb, whatever it is, and then they looked at the response. So that means the patient is awake when they respond. If they don't respond, patient is asleep. So that's the endpoint they looked at, and they defined that as a MAC awake. So that is the slow washout method. They kept that same concentration 15 minutes before altering it and looked at it at each level. And fast washout method, the end tidal concentration is allowed to fall fast by patient breathing spontaneously. The patient is allowed to breathe spontaneously. It is not controlled. So it is allowed to fall as the patient is washing it out. The concentration at which the patient responds to verbal command, again, is noted as midpoint between response to non-response to verbal commands. That is how they plotted. And what did they find? The MAC awake for halothane, this is absolute concentrations, 0.41, 2.2, 2.27, 1.6. And then they looked at the ratio between MAC to MAC awake. They were not happy with what is the absolute value of the agent. Is there a correlation between the MAC value and then the MAC awake? What's the ratio that is established? So you find it's 0.52 by the MAC awake by slow washout, 0.52 and 0.6. And in the fast washout, it is 0.33 and 0.34 for these agents. And for sevoflurane and isoflurane, it is 0.34 and 0.31 when it's a slow washout, and it is 0.22 when there is a fast washout. So there is a the MAC awake is 0.34 when there is a slow washout and 0.22 when it's a fast washout. So we have done a study here in our institute. I don't know how many of you are aware of that. And with desflurane, and this is an unpublished report. The MAC awake, when you do this is a fast washout where 10 liters of flow is given. When there is a fast washout, the MAC awake is 0.15. When there is a slow washout, it is 0.35 for desflurane. And okay, and the absolute value is 0.52 and 1.3. So there is a ratio between the MAC and MAC awake, and so we are just trying to equate it and say that the 0.3 of MAC is MAC awake, because most of the agent it is falling at 0.3, but it cannot be applied uniformly for all the agents. You have to individualize it to the technique that you are using and to the value to that particular agent. So though normally we say 0.3 MAC awake, 0.3 MAC is MAC awake and the patient is likely to wake up. It is not true uniformly for all agents. You will find that 0.3 for the fast slow washout in sevoflurane, it is 0.22 when there is a fast washout, And these agents, it varies from 0.5, 0.6. When it's a fast washout, it is 0.3. So this is being taken here, and this is being taken here, and this is being taken here, and then we are trying to say 0.3 Mac, the patient should wake up. And we are misinterpreting all the values that have been put forward by the researchers, and we are trying to make it uniform, and we should not be attempting that. We should be looking at it at the value, at the technique that you are using, and when the patient is likely to recover. So that interpretation should come depending on these things. Okay. Now, what is MAC bar? MAC bar is again described in 1981. The brain concentration of the agent at which blocks the adrenergic response to skin incision. Okay, we had a discussion last time about this adrenergic response or the autonomic response. Okay, what is accepted terminology? Adrenergic response. Okay. The response studied a typically increase in heart rate and the arterial blood pressure. Those were the responses. Because you have to have an endpoint for studying what is studied, the endpoints are heart rate and the arterial pressure. So it was coined as adrenergic response to skin incision. So they estimated this as a fraction of MAC. For halothane it is 1.45, iso it is 1.3. Sevoflurane stood out from all this. Here also it is 1.3, desflurane. But Sevo, it was 3.2. Why is it so, here when it is 1.3 here, why it is 3 times more for the sevoflurane? Because, and they said the mechanism of action of sevoflurane to produce this blockade is maybe slightly different, so the value is high. So unless you go up to this particular value, 3 times the MAC, you may not stop the adrenergic response when you're using sevoflurane. So you have to use some other agents to block that. And you should not be depending on this particular agent alone for producing that particular block. So what are the other agents that can be used? So the studies went on for sevoflurane, how we can reduce the MAC by adding up something, the MAC and MAC bar. So first thing they studied on is the fentanyl. What's the effect of fentanyl on MAC and MAC bar when you're using sevoflurane? So 1.5 mics per kg of fentanyl decreases the MAC by 50%. You find that this is what it is. When the MAC is here and you are given 1.5 micrograms per kg, the MAC came down by 50% from the actual value. Okay, what happened to the similar effect on the MAC bar? So here the MAC bar is here around 4%, and with 1.5 it came down to around 1.5. So, and this dotted line is CD95 and the solid line is CD50. So addition of fentanyl 1.5 max to sevoflurane anesthesia reduced the MAC by about 50%. That is finally. But adding up more than that, does it have any effect? So they increase the amount of fentanyl concentration 4, 6, 8, but there is a plateau and there is no further reduction in the MAC that is required. So you can bring it down by about 50%, not more than that. We cannot produce a total anesthesia with narcotic agents. Okay, similarly for MAC bar also it is the same. The ceiling effect and doubling the dose did not make an impact on the MAC. Okay, that's one thing. Then adding this narcotic, did it have an effect on the MAC awake? It did not have an effect on the MAC awake with sevoflurane. So they found that with a different age, 20, 40 and 60, the MAC awake remained the same in spite of increasing concentrations of fentanyl. Patients woke up at whatever is the concentration here, patients woke up at the same time, at the same MAC awake value. The 0.7 is 0.2. What's the MAC value for Sevo? 2. Okay, 0.7 is? What's the ratio? That's 0.3 MAC. Okay, I mean that is how 0.3 MAC is a MAC awake. That is how that things have come. 0.3 Mac is Mac awake. Now, what is the effect of regional block? What do you do when you do a regional block? You are blocking the nerves. There is total deafferentation. That means that no impulses go from the site of surgery back into the brain. You are blocking them all at that level. So if you do that, what should be the MAC level that you maintain? What should be the agent concentration that you maintain to keep the patient asleep? No? I mean, it naturally comes because noxious stimulus is the one which increases the amount of agent that you need. But if you totally cut off the noxious agent by giving a block, then what is the level that you should maintain when you give a general anesthesia? Okay, these blocks can produce immobility of the region. If this is accomplished, what should be the MAC target? Is it enough to reach MAC awake, or do we need to erase memory totally? So this is one of the areas we have also done the study. What we have done is to use anesthesia by using nitrous oxide, oxygen and sevoflurane. The endpoint is entropy between 40 and 60. What is entropy? What is entropy? Now get the habit of quickly switching your mind and coming to a definition or whatever is asked for. But we have talked about this entropy and MAC and BIS. What is entropy? Monitoring depth of anesthesia. Keep talking. If you don't talk, then the whole thing will be a one-sided, and after that you work out from there. Whatever we have talked about is gone out of your mind. What's entropy? Define it. Don't worry if you make a mistake. Nobody is going to blame you. Nobody is going to kill you. Talk. Keep talking. Tell something. One of the measures to see what is the depth of anesthesia. Okay, what does it do? What is done in that? What is the parameter that is being monitored? You are looking at a number, but what is based on what you are looking at a number? You need. We are looking at the EEG. What are we looking at the EEG in entropy? EEG is electrical activity of the brain, but what we are looking at that electrical activity when we talk about entropy? What do we look at when we talk about BIS? Is there a difference between the two? Both of them are based on the EEG. What is the difference between the two? The two monitors, are they totally different? Are they same? What is it? Okay, we have used an entropy here. This I am leaving it for you to reflect on and put it in the e-portfolio. I have given you 3-4 assignments. I have not seen any response so far that come back to me. I don't know. I have not seen any response from any of you in the e-portfolio. It has not come back to me. Have any of you put up? Then you please share it with me so that I can look at it. One person has said yes. Others are not confident to say yes, I have done it. You have done it or not done it? What? Then if you have, I don't even remember what are those questions. Unless I see somebody responding, I will not recollect. I will forget. So please respond so that I can look at it. Your consultants can look at it and correct you if there is a mistake. Okay, we have taken the endpoint as entropy between 40 and 50. And what we have done, we have used epidural with the 0.25% bupivacaine in one group and infusion of saline in the epidural space in another group. These are the two groups. All the rest of the things remain the same. Okay, so when there is a stepwise reduction, so we have changed the concentration at 10-minute intervals, giving a stabilization time of 10 minutes because we are using an agent which is much potent and then equilibrates much faster. So we are given a time of 10 minutes for changeover. So every 10 minutes, we use the same up and down method to look at it, and then we kept reducing it till the entropy showed increase beyond 60. Then we increase the anesthetic concentration to bring it back between 40 and 60. That is how the titration is done. And this is the group that is with an epidural, and it came down, the requirements came down, excepting in 2 patients where it remained at that level. And here, when he had infused saline, these patients, this is what is the response. The up and down is quite dramatic, and then the level also remained at a much higher level. So what is the interpretation? So when you looked at the end-tidal sevoflurane concentration, when we had given, this is the group with the epidural, the requirement end-tidal concentration of sevoflurane remained between at 0.5%. Okay, whereas in saline group, it remained around 0.9%. And if you look at the MAC is, here it is, we maintained the saline group, it's about 1.1, and in epidural group, it was 0.9. So there was a reduction about. Now remember, this includes 0.5 MAC contributed by nitrous oxide. Because we have used nitrous oxide, and at 50 to 60%, 0.5 MAC is contributed by nitrous oxide. So this is what the effect. And the reduction that we found is there's a 25% reduction in the MAC when you have used a regional block. So the suppression of the brain, because the afferent input is not there, has come down only by 25%. It is not that. You can go down by 70%. It's only by 25% you can go down, because you still have to maintain the patient's brain at a level where they do not react to the surroundings that is there. It is not just MAC awake. So there's a reduction of 25% in the MAC. Are we justified? The question comes, are we justified in equating the alveolar concentration with the brain concentration? We are all the time measuring a concentration in the alveoli, and we are saying that what we are talking about is what should be there in the brain. Are we justified in equating these two? Are these two same at all the time? They are not same. So what is the relation between the two? So we will use a simulation, and this is the Gassman simulation. So when at the start of anesthesia, the dark green is, this is the circuit concentration, this dark green is the alveolar concentration, and the red line represents the vessel-rich group. Okay, so there is a difference between what you administer in the circuit and what you reach in the alveoli and what is reached in the brain. So there is a time lag. Once you have cut off, once you have brought it down, it's about 5 minutes time they have equilibrated to all when you have brought down and kept it at that level. So there is a lag between what is there in the alveoli and what is the concentration in the brain. So that is at the start of anesthesia. But after you have got a steady state anesthesia, and all three of them remain the same. All of them remain the same. So that is why they said you have to give an equilibration period of some time. Vega and halothane, when they gave a time of 30 minutes before altering. And then when they studied the MAC awake level, they kept a transition time of 15 minutes. And when we have studied sevoflurane, we have kept a time of 10 minutes, so that there's a satisfactory equilibration between the alveoli and the vessel-rich groups at the time when you are making a measurement. Okay, that's what should be kept in mind. And if you look at it, what is the effect of cardiac output? If you look at it, if there is a fall in cardiac output, the alveolar concentration goes up. We will come to that, why it goes up. You may not understand why the alveolar concentration goes up, because the cardiac output comes down. And what happens to the age and the brain concentration? It follows, but it takes almost about 20 minutes to reach at the same level. It takes a much longer time to equilibrate in the brain when they fall in the cardiac output. And if there is a reduction, say if the cardiac output comes back to normal, and but the reduction is not at the same pace. The alveolar thing comes down immediately, but the brain concentration takes a long time to reach to that level. The race is slow, the fall also is slow. But if you increase it further at that when there is normal, again same way, the alveolar concentration goes down much faster, but the brain concentration follows, but at a much slower pace. There is a correlation, but the equilibration time between the two is much longer with change in cardiac output. Again, you look at why there should be a change with the cardiac output. We are talking about the gas transfer in the lung and then its transport to the brain. What does the cardiac output got to do with this transport? Okay, now what is the other correlation that is there? What about increase in age? So Mapleson in 1996 did a meta-analysis of all the studies and then came to a conclusion saying that there is a linear correlation for the log 10 of the MAC. So it is not a thing. If you can compute the log 10 of the requirement, there is a linear correlation and there is a reduction in the MAC as the age advances. So, and the formula that they have given is that MAC is equal to A is MAC at the age of 40 multiplied by 10 to the power of B. B value is 0.00269. X is the age of the person that you are trying to estimate. Okay, so that is the formula. So and so as the age goes up, and MAC at the age of 40, halothane is 0.75, ISO is 1.17, sevoflurane is 1.8, and desflurane is 6.6. These are the values that are taken at the age of 40, and they have computed and they have shown how much is the reduction as the age goes up, and that is the formula that they have arrived at. And so if you look at the latest machines that are coming and they incorporate this formula to give you, if you input the patient's age, it will compute what is the MAC for that age, and it is called MAC age adjusted MAC. So if it's a person is 80 years, it will automatically compute and tell you what is the MAC that you have achieved, and if it is 40, what is the MAC that you have achieved. So it will automatically compute and tell you, but not all the monitors does that. A few monitors that have come inside are incorporating that, and it is displayed as age adjusted MAC. Because you are likely to, if you are just looking at one value of MAC and for all age groups, and 80-year-old person, you might be overdosing twice the amount, and then say he had a complication. So you have to keep in mind as age advances, the MAC requirements also is coming down. So what are the other factors that increase the MAC or decrease the MAC? Okay, these are the things you should keep in mind. We have looked at some of them which increase or decrease. The MAO inhibitors, and what is TCA? Okay, and acute cocaine amphetamine use, ephedrine, levodopa, all of them which produce an increase in the adrenergic levels, all of them increase the MAC as well. Hyperthermia, hypernatremia also increase the MAC levels. I am just listing it out. I want you to interpret these. Why do these things increase the requirement of anesthetic? Same way, chronic alcohol use. ETOH is what? ETOH is what? Yeah. Ethyl alcohol. Okay. So chronic alcohol use increases the alcohol abuse, increases the MAC. What happens if it's an acute alcohol intoxication? It decreases. So they're quite sure about that. It decreases. Yeah. Okay. Apart from this, there is one genetic factor is there that they have identified. That is, red-headed females have a 19% increase in the MAC requirement compared to white-headed people. Okay, this is, they say this is genetically mediated. So red-headed females have a much higher requirement of MAC than the white-haired people. Okay. Now, what are the factors that decrease? Again, the first thing that you look at is the drugs. The ones that reduce the adrenergic output, they all decrease the MAC. The methyl dopa, rosapin, chronic amphetamine abuse, all of them reduce the MAC. And other drugs, opioids, benzodiazepine, barbiturates, alpha agonists, alpha 2 agonists, ketamine, all these agents reduce the requirement of MAC.